So now we're ready to get started. And this is a 3-step problem. We will change it to a 4-step problem. So when 710 grams of calcium is added to aluminum, how many moles of aluminum are produced? And just like yesterday, what type of reaction would you perceive this to be? Is it a synthesis? Is it a decomposition? Is it a double replacement, a single replacement, or a combustion? I hear single replacement, I hear double replacement. Does anyone have a more definitive answer? Well, first of all, what's calcium? Okay, Ca. Okay, so what is it added to? It's added to aluminum nitrate. So what is aluminum nitrate? Okay. Then, is this compound complete? Okay, because what's the charge of a nitrate ion? What's the charge of aluminum? Okay, so since that does not add up to 0, what do we need to do? Well, what's your least common multiple? Okay, so what's 3 divided by 1? Okay, so what do we need to do with this? Okay, so now we can proceed. It's a single replacement reaction. So what is the calcium replacing? Okay, so that means calcium is now replacing the aluminum. Do those numbers go over here for sure? Okay, this is part of the formula, so that has to go over there. And this got replaced, so there's our aluminum. Does this add up to 0? It does not. Calcium is a charge of +2. Nitrate is a charge of -. Okay, so what's the least common multiple between 1 and 2? So do we need anything here?
No.
What about here?
Yes.
Gesundheit. Okay. They said a 2, so I said Gesundheit. Yeah. 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 I don't know. We'll continue when everyone gets up off the floor from laughing. See, you can hear them in the background. Okay. So next thing, let's balance this. And the reason that this may look a little difficult is because you have these nitrates in pairs. These are in an odd number, so the best thing to do would be to get this up to an even number for nitrates. And how do you do that? Okay. And then what about over here? Okay. Really? 2, 3, 6? 2 times 3, 6? So 2. 3. Okay. Let's try 3 once. Okay.
And then you put another 3 in front of the first calcium.
All right. Is it now balanced? Yes, I believe so. Okay, so now we've got 710 grams of calcium. Okay, 710 grams of this. So on this side, it's asking for how many moles of aluminum, X amount of moles. We don't know. All right, so just like last semester, the very first thing that you would do when you have grams, you're probably going to change it to what? So 710 grams of calcium. Okay, that is our first step. We want to get rid of this calcium and convert it to a different substance, and the only way that you can do that is in a mole ratio. So how do we get rid of our calcium in our second step? Okay, so around 40. Okay, actually I think it's 0.08 grams of calcium, and you get a mole of calcium. Okay, so now we're in moles of calcium, and now we can get to the other side of the equation like we want and have to do. So how do we get rid of this next mole? Okay, moles of calcium to moles of what? Okay, because that's what we are looking for, is moles of aluminum. And we have a mole ratio, which means 3 moles of calcium. Now, don't do that. That might be a common mistake. We still see that from time to time. Why may someone believe they need to put a 3 here? But this is not a mole to mole ratio. Correct. This is. Okay. So, are we done then? Must be. We put the equal sign here. Something said, this looks like we can end that problem there. So what you would do, depending upon how you like punching these into your calculator, I'm punching this into my calculator. Is this a little excessive? Isn't that punching, though? Huh. Yep. Yeah, still works. Whew. Okay, so 710 times 2, that gives you 1420. Okay, so, and we'll come back to full circle here, 1420. Okay, because a lot of times there's just one number on the bottom. In this case, there is 2. So we need to take 40.08 times 3, and that gives you 120.24. 120.24. Now you can punch in or grab your answer. 1420 divided by 120.04, or 24. And we should get approximately 11.81 moles of aluminum. Okay, so if this was a 4-step problem, okay, if you have a really good understanding, we should be able to predict, and you would be able to tell me what should this say then instead of moles of aluminum. It would say grams of aluminum. Then you would have a 4-step problem. So how many grams of aluminum? Now, we don't need to reinvent the wheel here. In other words, starting all the way back from square one, you can. But what can you do in reference to this number? Notice we did mass to moles. This is a way to do moles to mass now. Okay? So in other words, what you had said, since we have that calculated, 11.81, that is moles of aluminum. How do we get this 2 grams of aluminum then? Okay, so moles of what though? Okay, and then what goes up on top? Okay, then, oh, well, we better do that, right? No, there's a 2 up here. Don't we put a 2 here? It's not a mole-to-mole ratio. Okay, so we're going to put 27 there. And once we do this, if we take 11.81 times 27, that would be 318.87 grams. 318 point, what did I say, 27? 87. I think. 318.87. Okay? One way, how can we check to make sure that this has to be right? Now we could start all over. Okay? And notice that when you get to this step, okay, you just be multiplying by 27 anyway. So let's see if we're doing this right. So 710 times 2 times 27, that gives you 38,340. But we're going to divide that by what, though? Has anything changed on the bottom here? No. We can put 120.24. Okay? So if we take this answer that we just calculated, divide that by 120.24, and we get, what a quinky-dink, 318.87. So then that tells us that not only is this right, but since we reworded this question, starting all the way back from the beginning, the only thing that has changed was we multiplied by 27. And that's what we're illustrating here. And you might be asking, well, you're multiplying by 11.18. Yes, we understand that, but mathematically speaking, this 11.81 ended right here. So then we took that 11.81 times 27 and got this. Or if this was changing mass to mass, multiplying everything out, you still come up with 318. So that means that has to be right. All right. So that does it for the 2-step, the 3-step, and the 4-step problems of action stoichiometry. Okay, and maybe so, maybe one of the easier ones. So rut row, we're good. Second row, third row. Okay, so I just basically look at this, and it just says review, 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 review. Kind of like pepperoni, pepperoni, pepperoni. Can anyone, who wants pepperoni, pepperoni, pepperoni? They're making one of the pepperoni, pepperoni, pepperoni. This is why they call it the pepperoni, pepperoni, pepperoni. Yeah, it's a Casey's commercial, I think. Yeah. Did we talk about it in A&P? I couldn't remember. Oh, okay. Well, sometimes I'm not here either, so it's. Oh. Are you sure? Sometimes I don't know either. Okay. So, and that's why it says review. We don't need to review the entire semester. I think it just makes more sense and it's better for yourselves to chop this up into bits, because I think that is a little overwhelming and just goes back to the same analogy. Okay? This is currently what we've learned, and then here is your semester. Okay? Anytime we try to dump this into here, you're probably just not going to retain it all at one time, okay? Because it's just going to start to overflow. Make sense? All right. So we will continue with this reviewing then on Friday, because Thursday and then Friday, because I don't think there's class tomorrow for awards day. All right, so we will continue with this on Thursday. Tune in next time to see if the calculator still works. All right, till then, catch up to you next time.